Hi, today we'll go over process measurement. So basically the PSP principles say that one should measure their work and analyze those measurements and improve from it. But for these measurements to be useful, it should be gathered for a specific purpose and managed and used effectively. If the measurements are done but they're not used in any way, then it's pointless and your process will not improve. The goal must be to then use and analyze those measurements in order to make some lasting improvements in your programming habits. So the purpose of process measurement should be to understand and then manage changes in your work style. So these measurements, the idea of doing it is so that we are able to predict and plan for the future better. And when I say plan for the future, any future projects that you work on, you're able to do better estimations and plan for it better. Also, the goal is to be able to compare products and use experiences from similar product or similar processes within an organization, or it could be even in a different organization. So basically we are using our past prior experiences and trying to incorporate that in predicting and planning for future projects. Also, one of the goals should be to adhere to standards, and that helps with measurement and keeping those measurements consistent. It's possible only when we adhere to the same kind of standards. And when I say standards, I mean standards for design, standards for code and testing. So the goal here is to establish a basis so that or a baseline so that we can then use that for making improvements. So there are different types of measurements, in process measurements that we could do, and these measurements could be in terms of software size, it could be in terms of effort, how much time, development time is spent on it, in terms of defects, in terms of cost. And these measurements are useful only if we can draw some correlations from it. So we need these correlations. That's what we will really use for future planning. So the correlations could be things like what is the program size and how many development hours does it correlate to. So then it makes sense to measure size, because then based on that size you can just begin to estimate how much time you might need to write code of that size. Similarly, cost distributions, coming up with the cost of for a particular project depending on its size or depending on the number of hours that need to be spent on developing it. Defect densities, how much time is it needed to do testing, and that depends on how many defects are we likely to introduce in a code that's of size, say, 1,000. Those are the kind of relationships that we're looking for, and that's the reason we're doing these measurements. So basically the bottom line is we want this predictive capability for future planning, so that we can take some actions to reduce the number of defects that we're introducing into the code, or improve our review quality based on how reviews happen in the past, and overall improve our productivity. So in PSP specifically, the kind of things that we're measuring are program size. What is the size of your program? And we'll talk a little bit more in detail about what does size mean. How much time is spent in each phase, and when I say each phase, the phases are like planning phase, requirements phase where you're understanding the requirements, design phase, and then the coding phase, testing phase, and then deployment phase. So how much time is spent in each of these phases in terms of minutes or hours depending on the size of the project. And then the number of defects found and injected, again by phase, and we want to break it down by phase because that's what will then help us think about improvements and in which phase are we supposed to be spending more time or more focus. Now when I say defects found and injected, so there is a phase when the defect is injected into the code or into the software system, and then there is a phase when it is actually detected, found, and then fixed. There's also a phase when it gets fixed. So maybe the defect got injected in the requirements phase itself. Maybe there was it's an issue with our understanding of the requirements due to which the defect was introduced, or it could be introduced in design, or maybe it's introduced in coding. And then it depends on when it was found. Was it found during a code review? Was it found during maybe a personal review or an inspection by some other person? It could be found during coding, compiling and testing. So we want to know when it was found and then when it was fixed. And then we want to keep track of how much time did it take to fix a particular defect. All of these things will then help us make improvements. So and whenever there's estimation, so basically we are estimating, and then we're also gathering the actual data so that we can compare the estimation against the actual to see how far apart are we, or how far away are we from the actual. And then it's okay if it's bad at the beginning, because we're learning from this process. But our goal should be to get our estimations as close as possible to the actual as we go through this process. So the measures that are derived from this data, our goal is to support planning, support better reporting to the management of where we are with our work, and characterize our process quality. So with the size measures, so the different kinds of sizes that we're going to be measuring, with PSP, our goal is to have a consistent size measure, because we're going to be using that information for future projects. So there has to be a consistent way of measuring size. We cannot measure size in one way for the first project and in a different way in the second project. Then that data is not really useful. So and then we have to establish a basis for normalizing the time and the defect data, again to make it useful, and in order to be able to better estimate in the future. So now based on this data that we have collected, our goal is to be able to answer some questions such as what sized program did I plan to develop originally, and then did I actually develop, so was the actual the same as that original estimate? How good was that size estimate? And then what was the completed size of the finished program? So these are the kind of questions we want to be able to answer, and then reflect on those answers and see what we can do to do better. So with the PSP processes, what we want to do is, for time measurement, what we want to do is determine how much time we spent in each PSP phase. Now this can be cumbersome. Now you're not going to be doing this all your life. It's only during this course to establish that discipline approach. So there is this additional step that you'll have to follow and basically measure how much time you're spending on each PSP phase. And then at the end of a project or an assignment, basically look and see how you can make those time estimates better. So you're going to be making estimates as well as measuring the actuals. So you'll be doing both of them. So you're going to be looking at how much time did I spend by PSP phase, and then how much time did I plan to spend by each PSP phase. So it's both the estimations and the actuals. Similarly, you will do the same thing for defects. In order to establish a baseline of defect data, you're going to, at the beginning, you're not going to do estimates. You're just going to measure how many defects you introduced or injected into the code. Again, we'll do this by phase. And then later on, once you have the baseline, then in subsequent assignments or projects, you will start estimating as well. So again, here also our goal is to answer the questions like how many defects did I make in each phase, how many defects did I remove in each phase, how much time did it take to find and fix each defect. So that's the kind of data that you're collecting. So coming to size versus development of efforts, I told you that we are looking at the program size with the hope that depending on that size, we'll be able to gauge the development effort. That's the reason we are doing it. So basically, how do we measure size of software? There are different measures in which it can be done. It could be, and it depends on the type of software system. It could be measured in terms of database elements if we are dealing with a database system, which is primarily database programming. So we could look at the number of tables that are in there, the number of relations that are in there. So different kinds of database elements, how many stored procedures are there, how many views are there, and that could help us come up with a size measure. But then there could be other kinds of software systems, which is mainly lines of code, like say a procedural language or an object-oriented programming language. Then that's where we can count the number of lines of code. There could be other systems where it might make sense to count the number of function points. Now, it may or may not make sense for all kinds of systems. That's the reason I'm saying that it all depends on the type of software system. Because functions or function points, all of them need not be of the same size. There could be a function that's of size 50 lines, and there could be another one that has 100 plus or even more number of lines. So the size can vary. But then if there's a software system where these function points are of similar in size, then the counting could be done in terms of those function points. Or if it's a UI based software system where there's heavy user interfaces, lots of user interfaces, then it makes sense to count in terms of, say, the pages or the number of screens or the number of reports, if it's a reporting kind of software system, or if it's documentation that we are trying to estimate for, then it could be in terms of number of pages of documents. So the size measure is sensitive to the language that we're using, the software system or the platform that we're using, and then based on that we should be doing the measurement. The size measurement should be in relationship to the development effort, and that's the reason pages are often an acceptable measure for document development, and lines of code is a good measure when we are dealing with source programs like languages like C, C++, Java or Python. And then there are other possible measures for other kind of software systems like function points or screens or modules or forms or database elements. And or maintenance fixes. So the measurement precision is important too, and when two people do the same thing, it's not necessary that they will get the same result. And so again and again, that's the reason I stress that here we are talking about your personal process and what your style of doing things is or of measuring is, and you maintain consistency in that measure because it's going to help you better estimate or better predict for the future. So again the measurements, when different people are doing it, they might for the same kind of problem definition, they might have different definitions of database elements and might end up with different number of database elements. Say for example, C++ lines of code, they cannot equate to assembler lines of code. And here we're talking about, say we're dealing with different kinds of programs. Again, the measurements between them also is not going to be the same. Again, looking at new lines of code versus modified lines of codes, it's not necessarily the same. Logical lines of code may not equal to physical lines of code, and there's a difference between that. So physical lines of code is the actual physical line that you see, including the blank lines, including the commented lines of code, whereas logical lines of code it goes by logic. So and they are not the same, and one person's C++ code may not be the same as another person's C++ code. So at the end of the day, it's about your personal development effort, and you need a precise measurement definition for your work because it's going to help you improve your productivity and quality in future projects. Let's talk a little bit about counting lines of code, and that is kind of tricky. It is not straightforward. Manual size counting is not possible, right? You can do that for small programs, but then that's not what we're going to be doing. We're going to write really huge programs eventually. You might start out with small ones, but eventually you're going to be working on huge projects. And manually counting is time consuming. It can be inaccurate. There are a number of automated counters, but they'll only work when there is a defined algorithm for doing the counting and for characterizing the product. So these counters, writing these automated counters is also complex. It's not straightforward. It depends highly on the size definition that's selected, the counting method that's used. So that needs to be provided in order to be able to come up with these automated counters. We can also talk about what is really suitable in terms of planning. What is a suitable measure when we are trying to think of size? Say, for example, if you're building a house, then typically it's the square footage that's used, and that's what predicts the cost. But then intuitively for people, we are able to better visualize at the beginning of of any job, and based on that visualization we can come up with a size prediction. So if you're talking about a house, then most people are able to visualize the house in terms of it's hard to visualize in terms of the living space, but it's more intuitive to visualize it in terms of the number of rooms. But then that intuitive size measure is not always correct. It could be used for initial planning, but it's not going to be accurate for further more accurate planning. The reason is, if you go with the number of rooms, we say 4 rooms, not all rooms may be of the same size. There could be one really large room and one that's comparatively very small. So it's not going to be an accurate measurement. So that's the issue. These intuitive size measures are not necessarily accurate. So we'll have to go with a measurement that is more accurate, and for the house, the square footage is what's more accurate, and it predict. That's what drives the cost. And that's same thing with software. We want to use what is directly measurable. Function points are intuitive, but they're not directly measurable for the reason that I mentioned earlier. The size of different functions can vary. There can be a huge variation. So it's not an accurate measure. Lines of code, on the other hand, it's not intuitive. It's very hard for us to visualize how many lines of code might be needed to solve a particular problem. But then it's measurable. It's directly measurable. So that's where we are. So how do we deal with this? So in terms of lines of code measurement, what PSP suggests is basically, again, the right thing to do is logical versus physical lines of code. Because logical lines of code is basically looking at statement specifications. What are executable lines of code? What are the non-executable lines of code? What are the different statement types? So that's what we're looking at. So and logical lines of code, they are invariant to editing changes. So even if changes are made, edits are made, the logical line of code is going to remain the same. And it does correlate with development effort. So it is something that can be uniquely defined, but it's very complex to count, to do the counting. On the other hand, physical lines of code, they're easy to count, but they're not invariant. Depending on the kind of editing changes that are made, and from person to person, it can change. These we need a precise definition. And what PSP says is to basically use coding standards so that our physical line counting becomes equal to logical line counting. And the way we can do that is by defining a coding standard. by defining a coding standard such that every physical line will become the same as the logical line. But then that standard must be faithfully followed. So that's how it's done. So here's an example of a function. So as you can see, there's a number of non-executable lines of code as well. There's blank lines. There's the begin and end, the keywords indicating the beginning of a block and the ending of a block. So what do we do with those? And sometimes even in all languages, things like a while statement or an if statement, if the conditions are long, it can be broken down into multiple lines and it's still valid syntax. Then how do we count that line? Do we count it as one statement or multiple statements? So that's where the issue is. So with PSP's counting standard, so we want to use a coding I'm going to stop that and redo just this slide. Okay. So we want to follow PSP's line of code counting standard, where we count all of the statements, including the begin and end statements of the blocks. We count if there's an if then else statement, then we count each of them individually. We count the open curly brace, the close curly brace, the ending semicolons, all of the declarations, the directives, the headers, the include headers that are at the top. So we count all of them, but then don't count any blank statements, don't count any comment lines, don't count any of the code that's automatically generated. A lot of IDEs do that. If you have UI elements, then and then if you use a visual editor to drag and drop those UI elements onto your form, then automatically code is generated behind the scenes for those, so we don't want to be counting those kind of auto-generated code and comments and such. And then basically use this as a way for measuring and estimating development productivity. So that way, when counting is done using this kind of a standard where your logical and physical lines of code are the same, then that will keep it consistent, and then you can use that same method across multiple programming tasks, so that you can then understand your style better and estimate and predict better for the future. So in terms of size accounting, this tracking can be done manually for small products, but then the moment the products get larger, we need better ways of doing it, and we need tools for doing it. Now also, as the size of the software gets large, there's multiple product versions, and then it quickly gets complicated to do size accounting. So to give you some examples, say we have a version 0 of a particular software, and say there's 350 lines of code in it. And then we enhance this version 0 to version 1. We add some enhancement to it, which includes adding say 125 lines of code. That includes the lines of code that were added as well as modified. So now, how do we do the accounting? So now, do we have 350 plus 125, 475 lines of code? That's what we would expect. But then, when measured, it's only 450 lines of code. Now, what does that mean? So if you remember, I said here it's 125 lines added and modified. Now, even the modified lines of code take some effort. There's development effort involved with those as well. So we need to be able to count them and then correlate and have corresponding development effort counted towards them. But then when we're doing the size accounting, this can get confusing and messy, because our measured size is now only 450 lines of code. So basically that's the reason we need a systematic way of doing this as well. So in this case, what might have happened is, with the base version 0, there were 350 lines of code. So we're keeping track of both added and subtracted. In the version 1, 25 lines were modified and 100 lines were added. So that's the 125 in the version 1 product. And then and then maybe 25 lines were deleted as well. So we need to take into consideration existing lines that were modified, and any deletions that were made. Now, deletions is also involving some effort. So we need to be mindful of these kind of things when we're doing the size measurement. But again, at the personal software process level, wherein you are dealing with your individual practices, the goal is also to use small tasks and do this measurement, do this estimation, tracking and analysis of your data for small tasks, so it's manageable. And then once it becomes habitual for those small tasks, even for future projects, and when you're on large projects, you can still break down your work into smaller tasks, and you will be able to estimate for those small tasks. Again, I want to repeat that this is not something that you're going to be doing throughout your career as a software engineer. No, it's just initially to establish a disciplined approach, and then once you've done that, it'll come automatically, and you don't need to track the data anymore. You'll just be able to do it naturally. But then what we want you to do is in this semester for this course, you do it over multiple activities in the project for each of the deliverables, so that by the time you're done with the course, you have a good sense, a good process, a good personal process, and you're ready to work effectively on teams. So that's the idea. So again, the important message to remember is we're doing all of these size measurements and all of the estimations and collecting the data. For this to be useful, we want you to reflect on it and analyze your work and see how you can do better for the future task. We want you to analyze and see which is the phase where you're taking more time or where your estimates are off, which is the phase where you're likely to inject more defects. How much time does it take for you to fix defects? So then you can begin to estimate that also, and basically take that into consideration in your planning for future work. So key thing is to use this data and make improvements for future tasks. That's all I have in this video. Thank you.